Hello everyone and welcome to our channel Mathematics School. Hope you all are doing great. So let's see what is the question for today in this 30 days 30 questions JEE Advanced series. Now we have the question as, let it be a function defined from closed interval 0 to 1 to r, be a continuous function. Be a continuous function. Find maximum value of integral 0 to 1 x square f of x dx minus integral 0 to 1 x into f square x dx. बहुत beautiful question है. Let us see and also remember how to handle these type of problems. ठीक है? Maximum minimum पूछा गया है for some integral. How we are going to get it? See, one way is getting the integral value and after that going for its maxima and minima. Alternatively, you should always keep in mind that maybe the question is meant to be solved by the method that I am sharing here. And it is not like that every question will be solved with this method. But you have to keep in mind कि ठीक है, एक approach है कि हम integrate कर लेंगे, differentiate करके maxima minima निकाल देंगे. मगर alternatively हो सकता है कि question को specially इसलिए frame किया गया हो ताकि आप इसी method से solve करें. क्या है वो method? अब हम check करते हैं. पहले मैं integral एक बार लिख लेती हूँ. So it is actually integral 0 to 1. दोनों ही integral 0 to 1 है, तो मैं दोनों को combine करके लिखूंगी. I'm taking minus x common and left out with f square x. Negative x common लिया तो minus x into f of x and then we have dx. So here is the question. Because we need to get its maxima minima, the problem is I don't have the function. How will I integrate it? यहीं पे major hint आपको मिल जाता है कि इसका मतलब अब आपको क्या करना है? Try to make a perfect square out of it. Okay, आपको एक perfect square बनाना है यहाँ पे. तो चलिए start करेंगे. Negative sign यहाँ रखा. 0 to 1, x as it is. But looking at these two terms, I'm getting the feeling that I must write fx minus x by 2 ka whole square. Right? I must write it like this. But if you're writing it like this, that means you're unnecessarily adding the term x square by 4. So subtract it. I subtracted it over here. Right? अभी क्या करना है? अब next step में I'm just going to multiply this x inside. अंदर multiply करते हैं, negative sign भी adjust कर लेते हैं. It will become 0 to 1. 0 to 1 क्या? If you adjust the negative sign, the first term will become x cubed by 4, while the second term will become x into fx minus x by 2 ka whole square dx. Correct? This is the integral I. Now what I have to do? The next thing that I'm going to write here in the next step is I will segregate the integrals. Can we integrate x cubed by 4? Yes. Minus integral 0 to 4. X is a positive quantity for the question because you are integrating it in the interval 0 to 1. And a perfect square quantity is always positive, which clearly indicates that I'm going to get here a non-negative answer, right? We will get here a non-negative answer out of this integral. What about x cubed by 4? We can integrate and we can get something from here, right? The question says that we need to find out the maximum value of this expression. To get its maximum, what you have to do is you have to subtract the minimum because it is a constant thing. It is not going to vary, but here, depending on the function, you will get its different values. What I need is its minimum. Minimum has to be subtracted. What is the minimum we can take? We can take the minimum of this expression as 0. When you take the function f of x is equals to x by 2, then this integral will turn out to be 0. So I can say that I की जो maximum value आएगी, that is going to be the value of this integral. So x cube का integration लिख लेते हैं हम और limit लगा देते हैं. So here is the answer that we have for the question, and it occurs when you take the function f of x as x by 2. So what you have to remember, if they are saying that get me the maximum or the minimum of some integral and they have not provided you the function. A function नहीं दिया है तो क्या करोगे? You are going to make the perfect square out of it and then you have to proceed to solve the question. ठीक है? Well, I really appreciate your engagement with the question. If you found the question enjoyable, useful, then consider giving the video a thumbs up, subscribing for future content, and sharing it with your friends. Look forward to seeing you in the next video. Until then, happy learning.